The SIGMET is a concise message written in abbreviated plain language which concerns the occurrence and/or expected occurrence of specific en route weather phenomena which may affect the safety of aircraft operations. These messages are issued by designated meteorological watch offices which have a responsibility for flight information regions, or FIRs. Messages containing SIGMET information for subsonic aircraft are simply identified as SIGMET, whereas those with SIGMET information for supersonic aircraft during transonic or supersonic flight are identified as SIGMET SST. SIGMETs are written in a very structured way, using a lot of abbreviated plain language. Many of these abbreviations you'll have seen before when we looked at the low-level significant weather charts, but a few may be new to you. The full list is displayed here, and you may want to spend a few minutes looking through it. We'll now see how a SIGMET message is built up, by looking at the individual components of a fictitious, though correctly structured, SIGMET message. The first component of the SIGMET is the location indicator of the Air Traffic Services Unit serving the flight information region or control area to which the SIGMET message refers. In our example, Yankee Uniform Charlie Charlie. This is followed by the word SIGMET, which acts as a message identifier. After the message identifier, a sequence number is shown. In our example, the sequence number is 5. This sequence number corresponds to the number of SIGMET messages issued for the flight information region since 0001 UTC on the day concerned. It's worth noting that the sequence of SIGMET messages is sometimes indicated by a combination of figures and letters. Next follows the date and time groups indicating the period of validity in UTC of the SIGMET message. In our example, the message is valid on the 22nd of the month from 12:15 UTC to 1600 UTC. The last set of characters on the first line of the SIGMET is the location indicator of the Meteorological Watch Office which produced the message. This is then followed by a hyphen to separate the preamble from the next line of text. In our example we have Yankee Uniform Delta Oscar hyphen. This completes the first line of information of the SIGMET. At the start of the second line we have the name of the flight information region or control area for which the SIGMET is issued. In our example we've used the fictitious name Amswell FIR. This is followed by the name and description of the phenomenon which is causing the issuance of the SIGMET. This will be abbreviated plain language extracted from the table of abbreviations which we saw earlier in this lesson. Here we have severe turbulence. After the name of the phenomenon, we have an indication of whether the information is observed and expected to continue, using the abbreviation OBS, or forecast, using the abbreviation FCST. Where relevant, the time of observation in UTC is also given. We have used OBS at 12:10 in our example to indicate that the severe turbulence was observed at 12:10 UTC. The next set of information refers to the location and altitude of the observed or forecast phenomenon. Where possible, reference is made to latitude and longitude, or locations or geographical features which are well known internationally. Examples of these are forecast top at flight level 390, south of 54 degrees north, and Shannick Oceanic at flight level 250. In our example, we'll use Yankee Uniform Sierra Bravo, flight level 250, which indicates that severe turbulence was observed at 12:10 UTC over FIR Yankee Uniform Sierra Bravo at flight level 250. Movement, or expected movement, of the phenomenon is provided for by reference to one of the 8 points of the compass. Speed is given in kilometers per hour, knots, or stationary, as appropriate. We've used MOV, E, 40 kilometers per hour, in our example, to indicate that the severe turbulence is moving east at 40 kilometers per hour. Finally, an indication is made of any changes in intensity of the phenomenon, using as appropriate the abbreviation for intensifying, weakening, or no change. We've chosen weakening in our example. Let's now put all of this together. Our fictitious SIGMET reads, the fifth SIGMET message issued for the Yankee Uniform Charlie Charlie Flight Information Region by the Yankee Uniform Delta Oscar Meteorological Watch Office since 0001 UTC. The message is valid from 12:15 UTC to 1600 UTC on the 22nd of the month. Severe turbulence is expected to move eastwards at 40 kilometers per hour and to weaken in intensity. When SIGMETs for volcanic ash clouds and tropical cyclones are issued, they include an additional line of text. This line contains a brief outlook forecast beyond the period of validity specified earlier in the message. This outlook will include a trajectory of the volcanic ash cloud or positions of the tropical cyclone center as appropriate. It's important that you familiarize yourself with the structure and nomenclature used in SIGMET messages. The correct interpretation of SIGMETs forms an essential element of successful flight planning and in-flight safety.